Hello. Uh, today's is just one of I try to demonstrate how to use Claude for one simple shell structure modeling and transfer to the structure software SAP2000. So here, if you have a Python, no, Rhino Grasshopper and Claude, maybe you can try out. Still just investigating how I can set it up and workflow by using Rhino Grasshopper with the Claude scripting capability. So here it is. I just found out one of the shell structure images. I pasted and said choose one simplest form and create a Grasshopper Python script. So the Claude actually gave me this script, right? So this is script. It's yeah, obviously it's a programming, and also the Claude give me some explanation of the input factor. It's all about dimension and some definition of a plane and output. So what I can show you here, this is Rhino 8 and Grasshopper. This is Python 3 script I use. I'm not sure this is really the fastest way to do this, but and then I just try to learn. So here, if you type the Python 3, you can open this, right? So when you open the script, basically you can double click and delete, select and delete. You better, oh, okay, hold on a second. You go to Claude, get the older script copy, and you can paste this, right? If you run it, I think there will be some the problem, which means you need to define the the inputs. So I think the Claude explained that all input and output parameters. So I think I already did it. So I'll show you the right click, and you this is uppercase, lowercase, very sensitive, so you need to follow along exactly, right? If you need to add more parameters, add the parameters, right? So here some one of parameter h representing height, I think divisions, xy, I think horizontal and vertical number of division, and some sometime there is something trinary and I have to gone through because sometimes it's not, there is something issue. So here is my the Grasshopper Python script. Let me get rid of it, and let me get rid of this the previous one. So this I'm just also close this, okay, and try to use this. Okay, so I input that, and let's see. So the output, I need to also add the mesh. And just sometimes compute. Okay, so it's sometimes it's not automatic, so I have to right click and recompute. So here, I think you generate the mesh, and also I'm gonna add a few more output. So second one is boundary, and third one is rips, right? And fourth one is point, PTS. Okay. All right. So when I recompute, you see that the surface first is mesh, is generated overall shape mesh, and also it shows some boundary. Maybe I guess its boundaries as four edges, and ribs representing all the ribs and line. So Okay, so basically the mesh is mesh. I think visually you could see this. Boundary seems like surface. Let's see, is it surface? Surface. Maybe this one is the same. I don't know. And rib is curve output. Okay, right? So you see that all the lines is belongs to is assigned to the rib. So basically here you could mesh, you could generate. And let me try mesh first, bake the mesh. When you do that, yeah, this is all one open mesh, right? So this is one open mesh. Let me try the boundary. What is this boundary? Oh, this boundary surface behind at the bottom. Okay, I probably don't need it. And rib, okay, rib is all curve. Oh, but okay, this open curve all connected together. All right. So this is something that I'm currently working on, learn some Claude, how to use a Claude, because I'm not good at all this scripting. Even though I have some the knowledge about Grasshopper, sometimes I having a hard time. So I think this is one of my learning uh, the work, how to use Claude and understand or create some kind of geometry. So first of all, this is the first shell structure. I mean, those are all geometry. It's parametric wise, so you could play with the old geometry, which is perfect, right? Number of now. Second one is I'm a structural engineer. In order to create this 3D model, what I need to do is I need some next step. So basically, I need these three options. I have been digging out how to use or convert those all the poly curve to the curve and surface. A mesh, I have to convert it to the surface. So here it is. So all the mesh, I can convert it to the face boundary polyline curve. No, actually, this is mesh. I'm gonna connect. So those all the mesh, I use a face boundary. So this one is polyline curve. So this polyline curve, I can broke make each piece of curve here. And this face boundary, this is poly curve, okay. And somehow I found out, but I don't understand 100% this continuity, and at least 1 2 3 4 seems like whatever just boundary polyline is broken into the point, right? So either it could be the 3 point or 4 point. I should be able to generate this surface. So long story short, let's see this curve. I'm gonna bake it, and also this surface. I'm gonna bake it. All right. So let's say if I move this one, I should have all broken, yes, surface and curve. So I'm gonna select and export this. Okay, I'm gonna call it this is shell 1, but I export to IGS file. I keep this is fit and fit. So I export into the .igs file, and let me just show you. Let me show you that I'm going to import that IGS file I created. Shell 1. So I'm going to choose this 2-layer, both curve and surface. So I brought just brought the all the line and surface. Is it everything right? Okay. All right. Now, as from here, this is all the engineering capabilities, right? So this is just only geometry translations. And what I'm gonna do, for example, maybe, okay, I'm gonna bring the material for, I'm gonna use HSS or steel pipe, but I'm gonna choose tube, HSS, material properties. I'm gonna choose one. I'm gonna bring some tube so I can, yeah, maybe try, let's say try 3 by 4, 3 by 5. Okay, and then shell, this is just not shell, I'm not relying on it. The first one is just a grid, geodesic or trapezoid, no, this is triangular shape, steel structure I'm gonna build. So shell is not real shell, I'm not relying on this shell element. This is dummy element. For, let's say, maybe I can just keep using steel, but I like to just minimize, ignore this stiffness, right? So this is kind of dummy member for assigning load. So this is 1 millimeter. Okay, 1 millimeter. All right, so default. So first of all, I'm gonna select all the member. I'm gonna assign the HSS steel, and then the other shell elements assign a dummy member, right? Okay, so next one is, maybe I can assign boundary conditions. Maybe I can select, or bottom. Do I have, no, I don't have it 0, 0. Okay. All right. So let me turn on the node. Okay, I'm gonna choose, put the all the 3D in XY plane. Hopefully I can choose all this. Okay, I assign the pin. Okay, let's see. Okay, all right, so this is just testing. So I'm gonna save the model. Okay, shell structure 1. So just run it for sulfide gravity. So it's because the default dead load sulfide is already assigned, defined. So I'm gonna run the model and see. All right, it ran. This is blocking my view. All right, so let's see, maybe deflection contour. Okay, animate. Okay, so this is deformation shape. Let me just rotate and see. Okay, and and take a look at the forces. Let's check the axial force. Okay, axial force diagram. Okay, and moment diagram. Okay, axial force diagram. All right. So basically, this is just the beginning. Just exercise how to use Python and to generate the geometry by using Rhino and Grasshopper. While you're generating a line and curve and shell, obviously it should be surface. You can translate all this into the SAP by using IGS file. Okay, so this is actually one of example.